This lesson is for students to use nets to represent prisms and find the surface area of prisms. My hope is that you'll actively participate on your own at your. That didn't make any sense at all. Let me start that again. All right, this video is to focus on the objective of using nets to represent prisms and find the surface area of prisms. You will be completing a Google form to answer some questions. You will need some scrap paper in order to complete the Google form, so be ready for that. And the bottom line is I want to know if you know how to find the area of the entire surface of a prism. Now in my previous video I did have some visual aids. Brought out a different cereal now. We're working with some frosted mini wheats. And so you can see this is a rectangular prism. And what we learned about rectangular prisms is we know that they have two bases and four lateral faces. And with prisms, that's interchangeable. So you can make the top and the bottom your bases, and then the front, back, and the sides your lateral faces. But the bottom line is there are 6 faces that construct this prism. So if I was to cut my box up, it would then become what we refer to as a net. And a net, we know, is a 2-dimensional representation of a 3-dimensional or a solid. And so what we're going to do to find out the surface area is we're going to find the area of every part of that net. And that will give us the surface area. So here's a good visual. It says the surface area of a solid is the sum of all the areas of its faces. You can use a 2-dimensional representation of a solid called a net to find the surface area of the solid. Surface area is measured in square units. So you can see they started with a 3-dimensional figure, they unfolded it, and created it. Now, I can't really color code this with the materials I have right here, but you'll notice that the top and the bottom of this box are the same. All right, the 2 sides are also the same, and then the back and the front are the same. And that's something you're going to note as you work through to find surface area. So we're going to do our very first example right here, and you'll see that this picture is it's labeled. So you can see the base, the height, and the width. Now if you were finding volume, you just multiply those 3 terms. Surface area is much more involved, and there's really no shortcuts because our objective is to use the net. So I don't want you to use a formula you might have found online that works for all prisms, because we need to understand the concept of the net as we move forward for our pyramids and for our triangular prisms. So one of the things that we have to realize is the relationship between our side lengths. Anytime we've got a side length that joins together, it's the same measure. So you see how those 2 5s, they would fold together to make this shape. And so they're going to be the same length. If you think about it, once I fold that, that means that this measure and this measure also to be the same length. So you can see that. After you've constructed your net, it's very helpful to label all those parts so you can find the area of each part. So here I have 7 and 5, which give me an area of 35, and this would be congruent. Here I've got a 7 and 3, which gives me an area of 21, and that will be congruent with this part here. And here we've got a 5 and a 3, which gives me an area of 15, which would be congruent here. So in order to find the surface area, I need to add up all 6 of these numbers. Now some students will make like a whole column of those numbers, 35, 21, 15, 35, 21, 15, and that's one strategy. But I think with 6 numbers that does potentially create some errors. So what I like to do is kind of group those equivalents. So those 2 35s equal 70, the 2 21s equal 42, and the 2 15s equal 30. And that's a nice strategy for adding that up nice and quickly and getting 142. Now remember, with our surface area, we are looking at an area. So our area would be in units squared. So when we get to volume later on in this unit, that'll be when we're dealing with 3 dimensions, and it will be a cubic unit. But with surface area, it's always going to be square units, just like any area. So here's an example that the book had done for us, very, very similar to one we just did. And so you can find this in your textbook in lessons 8.2. So if you want to kind of see some more examples, you could do that, or some colored examples, that helps. And you're going to see that once you find the area of each part, they're just adding them all up. One of the main things to watch for whenever you find surface area is consider how many faces there are and make sure you have that many areas. A common mistake students make when making their nets is they skip the lid. They're forgetting the top part of their figure, and as a result, they don't have the full figure. So you can see when you add it all up, you get your 122 square inches, and that was done for you. Now I'd like you to see this question. It's a little bit unique because it's a triangular prism, and to find the net of a triangular prism, it's going to have one less face because it only has 3 lateral faces instead of 4. But more importantly, we've got to realize that the two bases will be triangular, and so we're going to be using a different formula. So a real quick reminder of that, I've got two questions right here. Just to kind of remind you that if I want to find the area of a rectangle, I simply multiply 15 times 4 and I get 60 centimeters squared. That's no problem. But I can't do that with this triangle. We know with the triangle we use that there's a formula, 1/2 the base times the height. So we're going to multiply 1/2 times 12 times 8. And we used our associative property. You can switch around the order if we like. With the commutative property, I'm going to go ahead and do half of 12 is 6, then do 6 times 8 to get 48 inches squared. See, if someone had just multiplied the 8 times the 12 and gotten 96, that area is twice as big as it should be, and that is a common mistake students make when finding the surface area of a triangular prism, is they forget those triangles need that unique formula. So in this example, you'll notice that they found the area of the bottom by doing 8 times 12, the area of the side by doing 8 times 13, the area of this side by doing 8 times 5. But when they did the area of the triangular back, okay, they didn't do 5 times 12. You can see that area is 30. What they did was half of the base, which is 12, times the height, which is 5. And half of 12 is 6, and so 6 times 5 equals 30. And that's how they got that answer. So I do want to make sure you're encouraged to remember that as you do the triangular prisms, you must consider that. So I've got a couple examples of some nets. And so when you look at this and you see that there are 6 faces, you'll notice that in order to make this net, you always are going to need the 4 lateral faces kind of in a row, and then you need a top and a bottom. Okay? So if we put them both over here, they would both be on the bottom or they'd both be on the top. So your box kind of needs to look like this whenever you have a net. The numbers here are very, very small, so I'm just going to tell you that's a 5 and that's a 5. In fact, this is a cube, so the area of each is going to be 25 centimeters squared. So saving time here, all 6 of these are going to be congruent. So that's just going to be a 25 times 6 to find your surface area of 150 centimeters squared. This example, it's not going to have all equivalent parts. So you kind of got to look at where your numbers are. That's a 3 and a 9 for those of you who can't see that. So the area of this section will be 27. Since this also has a side length of 3, this would be 27. Since we're doing 9 times 6 for this one, we'd have 54. And this 6 by 9 would also be 54. And then our area here, 6 by 3, is 18. And another 18. And like I'd suggested before, I'm not a big fan of just making a column of 6 numbers. I like to group my numbers together. 54 and 54 is 108. 27 and 27 is 54. And 18 and 18 is 36. So 6 and 4 is 10, plus 8 is 18, carry the 1. 5 and 3 is 8, plus 1 is 9. And then we've got the 1. So 198 centimeters squared, noting I'm going to make sure I use the correct units. So again, with surface area, we're adding up all the surfaces to get that final surface area. So here's our first triangular prism. And I know it's a prism because all those lateral faces are rectangles. We spent all that time on that previous lesson talking about those lateral faces being rectangles rather than just saying, oh, it's pointy or not pointy. That helps us to create that net. So clearly 2 by 2, that's going to have an area of 4, an area of 4, an area of 4. But this triangle here, I'm going to use my formula 1/2 times 2 times 2. And half of 2 is 1, 1 times 2 is 2. So the area of each of these triangles is 2. So 4, 4, and 4 is 12, plus 2 is 14, plus 2 is 16, gives me a surface area of 16 inches squared. So I'm going to move on to one last example that I'm going to provide the net, and then we're going to have us try to create our own nets. So you'll notice that every time I've made a net of a rectangular prism, they're very similar, okay? Their style looks very much the same. And honestly, when you draw it, if your picture is not exactly the way it should look, but your numbers are accurate, that's going to be enough for me. You know, when I make a rectangular prism, it must have 6 faces. And then those numbers need to kind of match up to make sure it works. So as I look at this picture, it tells me that it is, this is supposed to be an M. So it's 5 meters by 9 meters by 6 meters. So when I look at this picture, this is clearly my 9 meters, okay? And then this would be my 6 meters. All right, if this is 6, that means this must be 6. And this is a good example because you can see that doesn't look like it's the same length. This picture was not drawn to scale, and that's okay. All right, now you know that we're going to have something that's 6 by 5 in order for that to be my side length as listed there. Okay, I can tell that this is the same as this, so that's going to be my 6. And that's going to be my 5. And so I actually have everything I need now to find the area of every single part. And I know that this picture is really, really dark. So I'm going to draw arrows to where my area is. If I'm doing 5 times 9, the area of this part right here would be 45. And the area of this part right here would be 9 times 6, which would be 54. And then this part right here would be 5 times 6 is 30. And we know that this one's also going to be 30. This one's also going to be 54, and this one's also going to be 45. So my 54 twice will be 108, my 45 twice will be 90, and my 30 twice will be 60. And I can go ahead and add that all up, and I get 258 meters squared. All right, so I've got 2 examples here that we're going to do. We've got a rectangular prism and a triangular prism. So actually we're going to work with just this one on this page, and then I've got another page, so I've got a little more space. So for this, I first need to draw my perspective. So I'm going to look at this little box right here as my starting point, and it is clearly labeled with a 6 and a 3. All right, and then I'm going to draw this top portion. Okay, I'll put that right above it. Okay, now hold on a second, Mr. G. If this is 3 and this is 6 and this is also 6, this must be my 9 right here. And that makes sense. Now this, on the other hand, this is going to match up on the other side. All right, and then this is going to match up on the other side. So that's going to be all 4 of my lateral faces. The only thing I need now are this side and this side. So what I want to do is I either want to extend them out here, or I want to extend them here. And it really doesn't matter, because whether it's here or if it's extended out sideways, I'm still covering both those sides of the box. The biggest thing I need to do is make sure I know the labels. If this is 3, this must be 3. So now I've got all my measurements. I can go ahead and find the area of the whole thing. So 3 times 6 gives me 18, so that'll be 18, and that'll be 18. 9 times 6, our ever popular 54. Okay, I'm going to circle these just to make it easier. You'll notice I didn't label them in my work because I will label them in my answer. And I've got to be cautious here. This 9 was this label here, not the area of this part. So if it's 9 by 3, that's a 27. So you can see why I'm circling that as I go. Now, I'm going to add again my 54 and my 54, which would be my 108. My 27 and 27, which is another 54. 18 and 18 is 36. I think these are the exact same dimensions in the one I did before, or I had done before, but that's okay. We can go ahead and add those numbers up. 4 and 6 is 10, plus 8 is 18. Carry the 1. 5 and 3 is 8, plus 1 is 9. Yeah, it is the same answer, 198 centimeters squared. So let's get to that final example, which is a triangular prism. And you're going to note with a triangular prism, you're still going to have those 3 lateral faces. I'm going to start with this one here on the front, okay? And I'm going to draw that right like that. And then I'm going to have this back part, and then this is the bottom. All right, and as long as I've got all my numbers covered, I should be okay. This is clearly 4, all right? And then this long side here would be the 5. And then this was also 4, and this was 3. So you could see my 5, my 3, and my 4. And that's how I got those 3 dimensions. And then finally, I've obviously got to have my 3 must be here, okay, to match up with that guy, okay? And then in order for this to connect to that, and then this would be a 4 in order for that to connect to this, right? Like that makes sense. Now, for my purposes here, because I want to work with a triangle that's easy to work with, I could instead have constructed it on this side so that I can have my right angle with the 4. But we're going to stick with this one right now, and we'll be fine. So we're going to go ahead and see that those are the dimensions of my triangle. So if I'm just doing this part right here, that's going to be 3 by 4. That's clearly 12. When I look at this part right here, that's going to be 5 by 4, which is clearly 20. And then this part right here is going to be 4 by 4, which is 16. My first triangle here, is going to look just like this, okay? My 5 and my 3 are the parts that meet at a right angle. So those are the numbers I have to use for my formula. And I know that that's not going to be super convenient to do 1/2 base times height, to do 1/2 times 5 times 3, but we're just going to have to work with what we have. Keep in mind that you do have 2 of those triangles, so if you wanted to, you could combine them, but I'm just going to go ahead and find the area of one of them. Half of 5 is 2.5, and 2.5 times 3, that does equal, let me pull this so you can see it better. 2.5 times 3 would equal 7.5. So 7.5 is the area of one of the triangles, but keep in mind we've got 2. So if we want to go ahead and just do the other one, it's also going to be 7.5. So my total is going to be 12, 20, 16, 7.5, and 7.5. Notice where I put my decimal point off here, and I can make each of these point zeros to line everything up. So the other thing is, many of you may have known that 7.5 and 7.5 adds up to 15, and just did 12, 20, 16, and 15, and that certainly would have been more efficient. As you add it all up, 5 and 6 is 11, plus 2 is 13, carry the 1, 1, 2, 3, 4, 5, 6. Your final area will be 63 yards squared. Now, this example was certainly a little bit overwhelming because of the added feature of those decimal negative numbers, or those decimal numbers, or those odd numbers for our parts of the triangle. But I know you guys can handle it because it's still the same concept we applied with the previous part. So just keep in mind, our goal is to be able to find surface area by making nets. So even if you're just successful making a net